Hello everyone, I'm going to show you how to make a wing with an aspect ratio of 6 and a taper ratio of 0.5 with a root chord length of 1 in XFLR. The first thing we're going to do is going to XFLR, open XFLR. Over here in Files, we're going to go to Module, we're going to go to Direct Foil Design, we're going to go to Foil, NAC foil. Going to type in our desired foil or desired NAC number. For my case is 2415. And number of panels, I'm going to leave it at 100. I'm going to call this OK. Right here you can see you get the outline of your NAC foil. I like to make this a little thicker so it's a lot easier to see, and maybe change the color to a color, more brighter color like red. Next, what you want to do is you want to go into direct X-foil direct analysis for your wing. You're going to go into analysis, advanced settings, and I am going to change my V actual to 0.001 and my iteration limit, I'm going to put it at 100. Next, I am going to analysis and define analysis. Right here, you're going to get all the information. I'm going to do a type 1 analysis with a Reynolds number of 300,000. Everything else looks fine. I'm going to click OK and then click Analyze. Close. Right here, this is your CP over X for your wing. But for us to be able to do it with, for the foil, for us to be able to do it with the wing, we're gonna have to do a batch analysis. By the way, make sure to make sure that this is clicked, and my analysis is going to be from -5 degrees to 20 degrees at a delta of 1 degree. Now, for us to be able to do the analyze the wing, we're going to do analyze, batch analyze, and over here, we're going to basically do whatever alpha changes you want to do. In my case, is from -5 degrees to 20 degrees in an interval of an increment of 1 degree. I'm going to click Analyze. We're going to leave this analyzer for a little bit. Might take a little bit, might be really fast, depending on how powerful your computer is. Once this is closed, we're going to see a bunch of lines here that sometimes, might be a bunch of nonsense, but it's going to work in our favor here. Once we're done with this, we're going to go to wing and plane design, and we're going to go to plane, define new plane. I'm going to call this my 2415 AR6 TP 0.5. I like to write these things down like this so I know what I'm looking at. It's my NACA 2415 with an aspect ratio of 6 and a taper ratio of 0.5. Because we only want to see the wings, we can get rid of the fins and the elevator. And now we're going to go to define for my wing. I'm going to set my chord to, I believe it's 1. And here, my offset is 0. And my aspect ratio has to be 6. I believe this is going to make it, what was it, 2.5? No, it's aspect ratio 3 here. My taper ratio is 1.0, so I'm gonna have to change this to 0.75 and 3.25. I think it is 3.25. No. 0.5 right here, taper ratio 0.5. Now we need the aspect ratio to be equal to 6. 2.25 was it? Right here, 2.25. We're going to leave everything else in 0. Now, the important part here is on the foil section, we're going to click here and select or foil, so that way it imports it and it knows what shape the wing is supposed to be taking. We're going to save, and then we're going to save again. Now right here, I'm gonna change this color to something bright like blue. And now I'm going to go to analysis, define an analysis. Over here, we're supposed to make this for 20 meters per second. An analysis LLT, plane inertia, wing platform projected in XY plane. This looks right, an extra drag we're gonna leave alone. And now we're going to save. Once this is done, we're going to click Analyze. And here it is. This is all of the data. If you want to take a look at other information here, which is not so sketching. Over here, we have access to our CL over CD graph, CL over alpha graph, and our CL over CD versus alpha graph. If you want to export it to Excel, all you really have to do is right-click, current graph, export graph, save it wherever you want. So let's say CLVCD. Save it. Go to the folder in which you saved it. In my case, it's going to be right here. VCD. And this is going to be your graph. Anyway, this is it for my project, for me and my partner. And thank you so much for watching.